Welcome back to Robbie's Office Hours. Today I have a doozy for you. It's an integration by parts where the integral actually becomes cyclical when you do integration by parts multiple times, all right? So this is one of those that when you see it, you're like, I have no idea what just happened, really confused, don't feel really enlightened. So what I want you to do is just take each step one step at a time. Does each step make sense to you, okay? The whole picture will come together with practice, but does each step make sense to you, okay? So here's what we're gonna do. I'm gonna call this integral, okay, and I'm gonna need every inch of this board because this is gonna take a little bit of space. So I'm gonna call I this integral, integral e to the 2x sine of x dx. Okay, I'm just gonna give it a name and you'll see why I'm giving it a name in just a moment, okay? So I'm going to do integration by parts on this. Now, it really doesn't matter what I choose for u and dv, okay? Remember, integration by parts says you have integral of u dv equals uv minus the integral of v du, and it's the antiderivative version of the product rule, okay? So what I'm gonna do is I'm just gonna choose u equal to e to the 2x, therefore du, which is the differential, so I take the derivative, e to the 2x, and I put the dx on the back end because it's a differential. And then dv will be everything that's left, so that's sine of x dx. And I say, what is v? Well, v is the function whose derivative is that, so that's minus cosine of x, just the antiderivative of sine, okay? So as a first step for I'm going to say this integral becomes what? So my formula up there says u times v, so this is minus e to the 2x times cosine of x, minus, well notice v du, look, v is negative already, so minus minus becomes plus, and I can take the 2 outside, integral of e to the 2x times cosine of x dx. Okay, so just as a quick overview of that, what is v times du? Well, it's negative 2 e to the 2x cosine x. So this would have been a negative 2 e to the 2x cos x dx, and since I have a minus from my formula, I can take out the negative, make it positive, and bring out the 2 as well. So I say, well, fantastic, integration by parts, kind of like saved my bacon, so to speak. And it's like, no, it didn't. It didn't, no, not at all, actually, because you just changed from e to the 2x sine x to e to the 2x cosine x. So you're like, okay, what do I do next? Well, think about it for 2 seconds. Look, if I did one iteration of integration by parts, and I simply change the integrand from e to the 2x sine x to e to the 2x cosine x, then it stands to reason that if I were to do integration by parts again with similar u and similar dv, then this will probably change back to my original integrand, okay? And that's why I'm labeling this thing I, and that's exactly what happens, okay? So let's see how this works. So I'm going to do another integration by parts. I can't use u and v again as the labels because I've already used u and v, so I'm going to give them different labels, okay? So I'm going to say u tilde, okay? That'll be the same as u, actually, because I'm just going to choose it to be e to the 2x. But I'm going to continue to use u tilde, simply saying that I'm using a second iteration of integration by parts, okay? And then so du tilde is the same, 2 e to the 2x dx, okay? dv tilde has to be cosine x dx then, so that's cosine of x dx, which means that v tilde is equal to sine of x from there, the antiderivative of cosine. Okay, fantastic. So this then becomes, let's see, minus e to the 2x cosine of x, that part's good, plus 2 times, okay, 2 times what? Well, this integral, again, is the uv minus v du, just with the u tildes and v tildes, okay? So what is this going to be? So it'll be an e to the 2x, so u tilde, v tilde, sine of x, minus v tilde du tilde. So the 2 can come out, integral of e to the 2x sine of x. And our intuition in doing a second integration by parts just panned out. Because look, what is that thing? That is I. That is what I'm looking for. That's why I gave this the name of I. Okay, so I'm going to do one step of algebra, and then we're going to finish the problem. So this one is minus e to the 2x cosine of x. I'm going to distribute this 2, okay, so I get plus 2 e to the 2x sine x minus, okay, what is this? This thing is I, all right? So what happens? I take the 2, I distribute it, I get minus 4 times I. Well, what's on the left side? Follow the equalities. Equals, 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 I. Fantastic. Solve for I. All right, so I'm going to move this over. I'm going to get 5I equals, I'm going to switch the order. This is just a personal thing. I don't like having the first term have a negative in the front, and since this is a positive, I'm just going to switch their order. That's not like a fast rule, but it's very common. Okay, so I'm going to put this as 2e to the 2x sine x minus e to the 2x cosine of x. All right, and I'm going to divide by 5 to get that my integral I, which was my original integral e to the 2x sine x dx, is equal to, take this whole thing, divide by 5, and put a plus c at the end of it because it's an indefinite integral. So what do I end up getting? I get a 2/5 e to the 2x sine of x minus 1/5 e to the 2x cosine of x plus c. Okay? So that, my friends, is how you evaluate integrals which they present as cyclic integrals, meaning they just cycle around back and forth over and over again after doing subsequent iterations of integration by parts. Okay? So as I mentioned at the beginning, if this whole thing was just like no idea what just happened here, take it one step at a time. Okay, do you understand how to do integration by parts the first time and write that out? Yes? Okay, fantastic. Do you understand how to do integration by parts the second time? Yes? Okay, fantastic. Did you understand that I called this thing I? You're like, not really. Didn't make a lot of sense. Go back and say, well, what did I call I in the first place? It was this integral, and that integral is appearing here. Oh, okay, so I can substitute I. The algebra allows me to solve for I, and I put the plus c because it's an indefinite integral. A lot of moving parts, a lot of difficult concepts, but at the end of the day, this is how you handle cyclic integrals using 2 iterations of integration by parts and a clever labeling of your integrals. All right, so I hope this was helpful. As always, like, subscribe, comment down below, ask me further questions about this, post questions, anything along those lines. I'm happy to post solutions to those, and we'll keep it rolling.